We are quickly approaching PlanetSmith's first playtest weekend, a chance for everyone to play an early version of the game for free. Details of how you can sign up to join the playtest will be at the end of the video. But before the playtest, I want to make sure as many of you as possible can play the game, even if you have an old PC or laptop without a graphics card. PlanetSmith currently consumes RAM at an alarming rate, putting even Chrome to shame. My PC has 64GB of RAM, and PlanetSmith manages to gobble all that up and ask for more. Also, it's not light on your graphics card either, and you have to have at least 8GB of video RAM to even run the game. So, it's time to put PlanetSmith on a diet. First thing I'm going to do is address the video RAM usage. Currently, each block texture is 512 by 512 pixels, and because the world needs to be rendered in one graphics pass, all the textures in the game have to be in the same image. This would be okay if we only had the 50 or so textures that are currently in the game. However, I wanted to future-proof myself and included the textures that don't exist yet by having blank placeholders. This has the advantage of getting ahead of problems rather than discovering them later, as adding thousands of new textures to the game won't affect performance at all. But this means the game has 6,144 textures to load into the graphics card. This consists of 6 gigantic 16,384 by 16,384 pixel images, which are 1GB each when loaded into video RAM. Automatically, this means that the game will struggle to run on any computer that has less than 8GB of video RAM. The way to fix this is to have bitmaps. These are downsized versions of the textures and are normally automatically generated. However, I am storing the textures as 2D arrays, which unfortunately doesn't have this feature. So instead, when I build the game in the editor, I'm making the bitmap versions and storing them separately, then loading the correct one from disk when we change the graphics settings. Now, onto the more worrying problem, the extreme RAM usage. Part of this problem is that all loaded chunks are uncompressed in RAM. Each chunk is 16 by 16 blocks in area and 512 blocks high, so will occupy 256 kilobytes of memory. Draw distance can go quite high, but for a draw distance of 64 chunks, that's 129 by 129 chunks, totaling 16,000 chunks loaded, which will use 4.2 gigabytes of memory. Even though that's uncompressed, and we can reduce that later, it seems totally reasonable and not the cause of our issue. It seems that something else is causing the problem. Taking a closer look, it seems that the memory usage gets larger the more of the world you explore. This should be happening. It looks like we have a memory leak. After profiling the game, it appears that it is mesh data getting out of control, telling me that something is going wrong with my pooling of mesh objects. It turns out the problem was twofold. First, I was using a native queue for the pooled chunks. Normally this would be fine, but I'm generating the whole pool on creation, as in a multi-threading process, we need a sync point to generate new chunks. Then, because a queue is last in, last out, all the possible chunks are cycled through, so chunks that have just been released go to the back of the queue. Again, this should be fine, but this is where the second part of the problem comes in. I was not clearing the mesh data when the chunks were unloaded and returned to the queue, so the mesh remained in memory until every chunk had been cycled through. With all that fixed, it's time to play the game on some old hardware. The oldest PC that I have is an Intel NUC from 2018 that has an 8th generation Core i7 and a Radeon RX Vega mobile graphics card, so definitely a low-end PC. Let's see how this tiny PC handles PlanetSmith. I'm starting with the graphics on the lowest setting, but it's performing super well. Draw distance is set to 320 blocks and it's running between 100 to 300 frames per second, even while cutting the world with a laser. Time to turn the graphics settings up to medium. FPS has now dropped to around 60 frames per second, and it feels really smooth to play. Because we're now heavily graphics limited, the game is still extremely smooth when destroying the world with the laser. I think this is good enough for most people now to be able to play the game, but I'm going to go one step further as there is something else I can improve. Now, I didn't talk about this during the raycasting or explosion video, but I was actually introducing a bottleneck and a race condition by writing those functions to be calculated per frame instead of inside the multi-threaded job system like everything else. The race condition isn't critical, that's why I wasn't worried about it at the time, but it's still not a great thing to have in your code. The fix is to, instead of having the raycasts being performed instantly, they are queued as an interaction and performed at the appropriate time inside a job. The job can then immediately queue any changes to blocks to take place inside the same tick, so to the player there is no difference from the previous method. The huge advantage is that the process runs around 100 times faster now, and means we can do tens of thousands of raycasts inside a single tick without causing any FPS drops. Also, it gets rid of any pesky race conditions by ordering the operation correctly inside a tick. A few of you commented that I should use raycasts for explosions in the previous video, and with this technique it may be possible for mid-size explosions. However, I still think I have an even better plan that I will do in the future once I've added properties to blocks like hardness that can still use the sphere casts and a clever A*-like algorithm, so stay tuned for that in the future. Time to test PlanetSmith on some even slower hardware. My phone. I've added a few thrown together touchscreen features so I can play the game, but other than that, this is exactly the same as the PC version. The main menu seems to be loading just fine. I'm going to set the graphics to low first and put the draw distance to 200 meters. That's 22 million hexels that will be loaded. Oh, it's loading in fast, and it looks to be playing just fine. I can break blocks and place blocks, and it's sitting at the capped 30 FPS with no drops. Now, for something a little more challenging. I'm going to fly up and get out my new boomstick. Time to create some damage. The phone is running great, no FPS drops even with all this destruction. And just like with the NUC, the laser wand is cutting smoothly through the world. Let's up the graphics to medium. This is doubling the textural resolution and enables the expensive volumetric atmosphere. Block breaking and placing still feels great. There is now a small FPS dip with the explosions and the laser, but it's still quite smooth. My phone is nothing special either. It's a Nothing 2 phone, which has an average CPU and GPU. This should mean that the game will run smoothly on just about any PC made in the past decade. It's also exciting to see the game running so well on a phone, with zero extra optimization done. Having PlanetSmith work on mobile is one of my future plans, and I want to have the mobile version be exactly the same as the PC version or console version, allowing for some extremely exciting crossplay opportunities. How cool would it be that after making some crazy world on your PC, you could load it up on your phone to continue playing while on a bus, or just show it off to a friend? Anyway, I'm getting ahead of myself. The focus for now is just for PC, and we have a long way to go before that can become a reality. Some of you may have already noticed, but I have also upgraded the UI. Until now, it wasn't really an issue, but I felt we needed to get a first draft of the UI into the game before the playtest. If you are not on our Discord, you may not have realized, but I have an artist, Sean, helping with all the textures, as their inventory is his design, so let us know in the comments what you think about it. The creative inventory has tabs for different block types, and our new items. Also, a handy search bar at the top. It uses a hexagonal grid to match the game, something that is actually really annoyingly complex to get working, as Unity wants you to use rectangles and doesn't have an inbuilt way to deal with this. So of course, I had to make this all custom. The toolbar at the bottom also has a cool hexagonal design. This split opinion on Discord, but I really like it. Let us know in the comments what you think. If this all looks exciting, and you want to play PlanetSmith, you can. Join our first playtest for free. To take part, just jump onto our Steam page, linked on screen now, or in the description, and click the Register for Playtest button. This playtest is all about creative mode, as survival mode isn't ready yet. To celebrate this, we're running a friendly building time-lapse competition. To take part in the competition, all you have to do is use PlanetSmith's inbuilt time-lapse function to record yourself making something cool. Then, post it on our Discord. Everyone who submits a time-lapse will get a special Playtest 1 role on Discord, and at the end I will pick some favourites. I'll make a video on how to use all the time-lapse features before the playtest. You can join our Discord with the link on screen now, or in the description. It's the best place to ask me questions and get all the latest PlanetSmith updates. Finally, I'd like to thank our YouTube members for all your support. You're helping me up the production quality of these videos. And if you're excited for PlanetSmith, don't forget to subscribe here on YouTube. It's one of the best ways you can support PlanetSmith. Helping our community grow is the way we make PlanetSmith a success. Thanks for watching, and I'll see you in the next video.